This is TWIS. This Week in Science, episode number 870, recorded on Wednesday, April 6th, 2022. Are brains or brawn better? I'm Dr. Kiki, and tonight on This Week in Science, we will fill your heads with honey tech, squid games, and fungal phenomena. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. Recently, a brawny Republican U.S. Senate candidate asked a question. He said, "At one time, science said man came from apes. If that is true, why are there still apes? Think about it." Okay, I will. First of all, if there were no apes, there would be no humans, since humans are a kind of ape, mostly hairless bipedal ape with a big brain and great technology, but an ape all the same. What's striking, though, to me is that this creationist hot take has been around for a really long time. Comedian Tim Allen posted almost the exact thing 5 years back on Twitter. He said, if we evolved from apes, why are there still apes? Again, the answer is if there were no apes, there would be no humans, no Twitter, no Tim Allen, and no way to answer the question, because we would not exist. So it's a bit like asking, if a tree falls in a forest and no one is there to hear it, does it still make a sound? And the answer to that is, of course, yes, because that's how object permanence works, something babies learn in their first year. But philosophers spent centuries worrying about this until science came along. If we can interpret the original question to be asking why are there still other apes, it just reveals the cartoon of evolution that they are still working with in their heads. It's wrong. It's just wrong. And we can blame science communicators past for that. The infographic of a chimp-like creature slowly becoming upright as evolution transitions from knuckle dragging to bipedal, from hunched over caveman to a modern day upright posture, is fundamentally incorrect. Nowhere in the 6 million-ish year human ancestral record did our forebear apes walk on their knuckles. Not like a chimpanzee, not like a gorilla. We were pretty much upright from the beginning. That is something other apes have evolved into. The longer fingers for climbing and the knuckle walking is relatively new because they evolved that way. We have a common ancestor, one that likely climbed trees and walked bipedally back and forth. But evolution isn't linear. Since that time, we and the other apes experienced different pressures. We evolved in different directions, and it is actually a really good example of how evolution works. And it's the same reason sharks are fish, and yet there are other fish. Why people have pet cats, and yet there are still lions and tigers. Why there are over 1,000 species of bat, 10,000 species of bird. And while there were several species of humans living at the same time, we are now down to one. Though through our DNA, the traces are there of past interminglings, which means they never really left us altogether. So the question, why are there still apes, is actually a really good one to think about. There are still apes because without them, we wouldn't have This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki. And it's just Kiki. No Blair.
It's just the two of us. just the two of us. We can science if we try. Oh, yeah. We are here to talk about so much amazing science this week, and we're so glad that you are here with us because we do enjoy this thing called talking about science. This week in science, welcome everyone. Our show ahead. What do I have? I have stories, news stories about the climate countdown. Dun dun dun. Brains versus brawn and fungi that just might phone home. What do you have, Justin?
Home fungi. Oh gosh, what did I bring today? I have a honey tech industry news update, which actually will be the first of its kind that we've done on the show, I believe. Let's see.
Honey Tech
We're,
Industries Incorporated.
yeah, I've got evolution versus racism, accelerating drug discovery in a bubble. EPA is going to cancel something that most people probably thought was already canceled, already banned. And in the Justin's Animal Corner segment of the show, the secret life of squid will be revealed.
Oh, squid have so many secrets. They have a very secret life below the ocean
Mhm.
surface as it is. All right, so we get to dig into secret lives and I don't know, canceling. What? Okay. I'm interested
Yeah.
about all these things, and I hope that you are as well. As we jump into the show, I do need to remind you that if you're not yet subscribed, you can find us all places that podcasts are found. We do broadcast live on YouTube, Twitch, and Facebook every Wednesday evening at 8 p.m. Pacific time. You can find us by searching for This Week in Science. We are also TWIS Science on Twitch, Twitter, and Instagram. Our website is twis.org. Now it's time for the science. Do you want to count down? 10, 9, 8.
Wait.
Oh,
What are we counting down to? It's very important. I know that. I
oh,
need to either
oh,
be hiding or like
just
have a camera ready.
yeah, just too much carbon dioxide in the atmosphere and temperatures going above 1.5 degrees Celsius, and when that's going to happen, and how much time we have left to make changes to the way that we do daily stuff.
Okay, so it is the go and hide one.
No, I am not gonna say it's the go and hide one because this is part of well, the international wow, what does the P stand for? IPCC.
International people.
People, no,
uh,
no, it's not. I just completely blanked on what the P stands for in the IPCC. Anyway, IPCC, uh, Intergovernmental Panel on Climate Change. It's much bigger than a panel, though. It's hundreds of scientists working together with policymakers, government officials, business people to try and get the clearest message out about climate change science and things that we can do, strategies for approaching this very serious issue in our world. This latest report they just put out is part 3 of the 6th Intergovernmental Panel on Climate Change report. And this part 3 stresses that we need to do something now, that we're running out of time. And you
Good,
might,
because I thought, as I recall, all the previous iterations
oh, yeah.
of this, they were like, plenty of time. No, nothing to worry about here. We looked at it. It's fine.
Yeah, so back the first part, the first couple parts of this 6th panel report, they discovered that things are a lot worse than they thought they were. So the models are actually underestimating how much things are changing and how quickly they're changing. And so the clock has gotten run forward a little bit faster. So
Yeah.
this report,
And I'm sorry, I did interrupt again. I feel like that's been every report.
yeah, it
Like I feel
basically,
like they
because what
keep the
happens,
more data we get, the more they're like, ooh, oh, oh, don't even. Oh gosh, oh, like it's just there's not been like They
Well,
haven't
you
come out with
really
the ones like,
hope that it's
hey,
going to be like, "Hey, everything's okay, like, we got
we
more data and
overestimated,
everything's better," but
or
that's not
yeah.
what our understanding is actually giving us more information on how dire the situation is. We need to do something. This report was approved by 195 governments, and the negotiating session for this third part of the report ran over schedule because there were different groups, Russia and Saudi Arabia in particular, who were pushing to like soften up the language about what we need to do about fossil fuels. Um, but they didn't soften that language up. This is a 2,900-page report, and it focuses on our options. How we need to curb emissions, how we need to capture carbon, how we need to mitigate these global warming impacts. Hundreds of scientists, 65 countries involved, they all came up with their scientific language for what they wanted to say. And then they had to work with the politicians. And the politicians were like, no, well, I mean, you're saying this, but you really say this, right? And then the scientist had to say, no, I wasn't saying that at all. I really want to say this. And the politicians come back and go, you don't really want to say that because we can't really do that. And so they went back and forth and back and forth. The politicians really, really working, which is what has happened in all of the other IPCC reports previously. The politicians really working to soften the reports and soften the blow and make it not seem as bad as it is because nobody wants doom and gloom. So, this time around, the scientists are really coming out of the woodwork to say this is serious. We need to do something. We need to have done it yesterday. So, yesterday won't work. So, let's do it today. We can't wait till tomorrow. We have today. Just like, what do you always say, Justin?
Now is the moment in which you can do.
And that is exactly what the scientists are saying about climate change. And this report does say that we have the scientific understanding and the technology currently to address this. It's a matter of will and it's a matter of politics and economics as to how we do this. So there were key points from the report. This suggests that global emissions need to peak at the latest by 2025 and then decline rapidly for us to have a 50% chance of limiting warming to 1.5 degrees Celsius. Um, 2030 and hit net zero in the early 2050s in order to meet the goal. And given what we're currently doing, we're probably going to more likely hit 3 degrees Celsius rise above pre industrial levels. So we're overshooting significantly at this point. So we have also price drops. So that was the bad news. Good news: wind, solar, batteries, all these technologies, prices are going down because we've had enough investment over a long period of time. The technologies are advancing, and we actually have and we have momentum behind them. And so these technologies are becoming better and more easily available and effective. Um, and in fact, global energy intensity, which is, according to this Nature report, a measure of the amount of energy required to drive the economy, it decreased 2% annually between 2010 and 2019, which is that's a great trend. We're reversing what we've been doing previously. So we're on the right track. We just have to keep going and more. So let's see. We need to also only slightly really we need to stop all of our fossil fuel emissions. We need to keep fossil fuels in the ground and that the existing and planned fossil fuel projects are going to exceed our carbon budget. It's too what we're planning is too much. We got to change track. Maybe those planned fossil fuel projects, turn them to nuclear, turn them wind, solar, figure out what else we can do because that's what we need to do.
Yeah,
We
I mean, nuclear has like that one immediate draw, right? Which is that it's carbon free. But then it also has that
And then you dig a hole and you put the radiation on the waste underneath the ground, or what we do is we get the bacteria to come and eat it up.
eventually, but we don't have that yet, right?
But we don't
So,
have them
so
yet,
then,
but we will
well,
someday.
the problem with the nuclear is then we're talking about a waste that is toxic for tens of thousands of years. Now,
Yes. But if it's hidden away, you'll never know it's there. Anyway,
Well, yeah,
moving
except
forward, I'm not going to debate this
oh,
right now. This isn't part of
okay,
this particular topic. I'm just
okay.
stating the findings of the IPCC. Um,
Yes, yes.
so we need to expand forests, improve agricultural practices. There are technologies that we can subsidize, carbon capture technologies, and also we need to we need to find ways to get carbon out of the atmosphere. And additionally, good news from this is that there we are looking at global economic growth slowing a bit if we implement all of the changes that are necessary for fixing climate change. But climate policies will reap later economic benefits through improved health and reduced climate damages. So it will balance out eventually. It's just not going to be a right now kind of thing. So this is we have to look at things from a long-term planning perspective and not a short-term perspective. Um, and wealthy nations need to financially assist low-income countries because low-income countries very often are not the ones that are causing the problems and are most impacted by climate change. So these are the big newses from the IPCC report. The big take home is you could be sad today, hide under your blanket. Nope, nope, nope. Get up. Get up. We have work to do. Okay? That's what we got to do. We have to and we are really at a point where it's technology, it's political. We need to get corporations and policymakers to move on this rapidly. This is where we need to go.
Yeah, and there's that thing you were saying at the top about how in the past the government, I don't know, maybe currently the government has been United States government has tried to water down information, or how the politicians are like, well, let's
Yeah.
change the language. Da, 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 da. That's not a thing that they would be willing to walk out on that thin rope and reinterpret military intelligence. Military intelligence saying, hey, here's the threat assessment of XYZ. It's like, yeah, but let's change the words. What do you mean? What are you talking about? Change the words. We just gave you,
Yeah.
this is intel. Yeah, but we don't like it. So we
Right.
want you to come up with a different way of thinking about whatever it is. You have some of the brightest minds out there, the educated folks out there who've been studying this for years, who are giving you intel, giving you results, giving you the latest data. It's just like, yeah, we're gonna change the data intel that we're getting. Now, that's not the point.
Yeah.
That's not the point.
Your desk. Why don't you take your desk and move it down into the basement?
Yeah, but keep it just the red swing line is actually this is mine. This is not
It's
from
my
the
my
company.
stapler.
This is my stapler.
Yeah, but good news. I'm bringing a good news story, Justin. Just
Mm-hmm.
good news. Kiki's good news. We do finally have eyes in the sky to really make our detection of carbon dioxide emissions more close to real time. I mean, not real time, but at least analyzed and understood within a month or two,
Hmm.
which is much better than we have done previously. New report is out now using data from NASA's Orbiting Carbon Observatory 2, the OCO2, and also the GEOS Goddard Earth Observing System. And they were able to measure drops in CO2 emissions during the COVID-19 pandemic from space. They have daily and monthly data products available to the public. So this opens new possibilities for tracking the collective efforts of human activities on carbon dioxide concentrations in near real time. So there's some pretty fun stuff out there showing that, yes, we did have a drop in carbon dioxide when everybody stayed indoors and stayed home. It happened. It was great. We can do it again. But now we can really see what we're doing and when we're doing it and what's influencing, what weather patterns are influencing, what fires are doing to influence we can see where all of these different sources are coming from and how the dynamics of carbon dioxide in the atmosphere are changing day to day. So, with the OCO2, you too could keep an eye on carbon dioxide. Eyes on the sky. Tell me a story.
Okay. Move over, high-tech industry. Now there's something way sweeter and stickier too. The honey tech industry.
I'm a fan. I love this.
Yeah.
I'm in. I'm buying
So
stock right now.
researchers have been looking into creating more biodegradable, renewable solutions for the next wave, the next generation of computers and computing power. Which one of the main candidates of is neuromorphic computers. These are systems designed to mimic the way the human brain works. One of the interesting things about the human brain is that it's really amazing. Really, it can do a lot if
You
you
think?
use it. Yes. And it uses very little energy. And actually not a tremendous amount of space compared to some supercomputers and what have you in the world. So this is Feng Zhao, associate professor of Washington State University School of Engineering and Computer Science. He thinks that honey is going to be perhaps the material of the future.
I
that
need you
brings
to
about.
explain this. You need to explain
Well,
this now.
I can't. I just
Be my
giggle at the
science
idea.
honeypot.
But this is Zhao. He says honey does not spoil. It has a very low moisture concentration, so bacteria cannot survive in it. And this means the computer chips will be very stable and reliable for a very long time. And their engineers have been able to use honey to make a memristor, which is a computer component similar to a transistor that can not just process, but also store data in memory. This is published in the Journal of Physics D. The researchers show that honey can be used to make memristors. Further quoting Zhao, this is a very small device with a simple structure, but it has very similar functions to a human neuron. This means if we can integrate millions or billions of these honey memristors together, they can be made into a neuromorphic system that functions much like a human brain. So they tested honey memristors' ability to mimic the work of synapses with high switching on and off speeds of 100 and then 500 nanoseconds, respectively. The memristors also emulated the synapse functions known as spike timing, independent plasticity, and spike rate dependent plasticity, which are responsible for learning processes in the human brain. And they've got this down to they're working on getting it to smaller and smaller scales. The team is working right now to develop them on a 1/1000th of a human hair and bundle many millions or even billions of these together so that they can create a supercomputer made out of honey components. So, and one of the things that they kind of point out too is the Fugaku supercomputer uses upwards of 28 million watts. Human brain
Uses
between
much
10 and
less.
20. Yeah, like we're not like when people are like, "Oh, that guy is not the brightest bulb in the." Actually, none of us are. We've been running on LED brains for a really long time.
Or at least low lumen bulbs, that's for sure.
So this is also, biomorphic computers, organic sourced materials. You have to, Zhao points out, it's like, it means you would have to avoid spilling coffee on these computers of the future. But then he points out,
you don't want to spill coffee on your computers already.
That's
It's really
already
a
a
poor
thing.
idea.
So there you go.
This is fascinating. I mean, I would love to know more about the physical properties of solid honey, right? So, I mean,
Mhm.
I know honey when you leave it in the jar and it crystallizes and gets hard, but no, it doesn't necessarily spoil, and you can always heat it up and it melts, and then uh, you can use the honey again.
Mhm.
Yeah, I would love to know more about how they created this and
That
more
was
of the reasoning behind really, I mean, yes, it doesn't spoil, but why really,
well,
why
'cause
honey?
I thought that same thing. Like the computers get heat going on in there. Like, so then, like the honey, like you said, you warm it up, and then all of your circuitry like oozes away once it's heated
Yeah,
up.
so did they add something to the honey to make this organic insulator, this organic material,
Yeah.
work in a particular way? Is it just honey? What kind of honey? Does it have to be like clover honey, or can it be something else?
So they've
This
been
is
working with a lot of things. So
fascinating.
he's been, I guess, working on different organic materials that could be used to
Mhm.
replace the more toxic components that we have in computers currently.
Yeah,
Uh,
great.
and so it's sugars, it's different proteins. One of the other ones that they got a lot of pretty deep into was like aloe vera plants
Yeah,
producing. So they really way outside of the box,
yeah.
but finding things that can work, finding replacements for the current components.
Green, sustainable electronics,
Mhm.
possibly. Very cool. Speaking of green electronics, how about solar panels that work at night?
Oh, by starlight, or are they digging infrared? What are they doing?
Yeah, so we've talked previously about research that uses thermoelectric gradients to produce energy just based on the difference between temperatures
Oh,
between
yeah.
the ground and the air.
Mhm.
And in this particular case, these researchers at Stanford University, who have published in Applied Physics Letters, AIP Publishing, they've constructed a photovoltaic cell that does the photovoltaic thing during the day, gets solar energy during the day, but then at night takes advantage of the thermoelectric gradient and radiative cooling. They have a heat sink that is underneath the solar cell, and that heat difference, is just enough to allow for a thermoelectric effect that allows for the creation of electricity because of that temperature difference. And this product that they've created, they say is completely off the shelf. They did not specifically like fine tune it so that the nighttime radiative cooling parts work more efficiently with the solar parts, and they say that you could probably and they might work on it to create something that can be more efficient. But with what they've done here, this is really engineered just to see if it would work. And they say the most expensive thing in the whole setup was the thermoelectric itself. What we managed to do here is build the whole thing from off the shelf and components, have a very good thermal contact, and and that was the most expensive thing was the thermoelectric. Um, they are going to optimize it, but the energy output that they had was on par with normal solar cells, and the fact that it continued to put energy into the system overnight was pretty good. And they say that the device generates 50 milliwatts per square meter. So you would need about 20 square meters of one of these of photovoltaic area, which is an easy roof to make that work. Less
Yeah,
than a roof. Yeah.
yeah. Yeah, you were saying this is sort of the first story in the show or top of the show or something about the price drops for
Yep.
solar and stuff. It's absolutely affordable and accessible now. Like
Hmm.
it's never been done, never been before. Great time if you're in that position. You can put some solar panels on the roof. Go for it.
Absolutely. And additionally, in addition, other good news. I've got this is the part of the early stories, which is solutions oriented. Rice University has created a method for turning waste plastic into a carbon dioxide absorbent material.
Okay, so now please tell me that this is not a plastic industry's attempt to say, hey, plastic waste actually good for the environment.
I don't know, but I really hope so. This work was supported. I'm looking down further. The work
Uh,
was supported by the Department of Energy, which that's great. Department of Energy wants to deal with energy issues, and
Depending on
Saudi
the year.
Aramco, which is a fossil fuel company. So there's some yeah interesting points here. But what they've done is they have a chemical process. It's a process called pyralization. They pyralize the plastic, and this is usually during the plastic recycling process. But if they pyralize it in the presence of potassium acetate, it creates porous particles of the plastic that are able to capture up to 18% of their own weight in carbon dioxide at room temperature.
Wow.
Yeah, so it doesn't need to be especially heated, but they can
Yeah.
create these things. So the question is, what happens to these plastics after they've they've absorbed all the carbon dioxide? What do you
Well, then
do?
we
Do you
melt them down in a furnace and
and release the carbon dioxide? Yeah, I mean, great if you're trying to capture the carbon dioxide to, I don't know, make more bubbly water, which is possible. Um, Yeah, it seems like a fairly simple process. The lab estimates the cost of carbon dioxide capture from a point source like post-combustion flue gas would be $21 a ton, which is very inexpensive. And if it's using waste plastic, that is potentially a good use for a lot of that plastic waste out there.
yeah, I guess there's a the plastic waste, meaning the plastic that's unrecyclable. Is that what it would?
Yes.
Okay.
Yes. Exactly. Waste plastic.
So we just need to figure out how to make more of that.
We don't need to
And
make more waste plastic. We have
no,
plenty. I think we have enough
that would be
waste plastic to last us to absorb carbon dioxide for the next century. If yeah, but it's an interesting technology. So just another point that the technology we have the technology now to do the things that we hope that we can do. Are you going to tell me
getting
about
more.
sparkles now?
Yeah, this is okay. So, question: how many different molecules can you synthesize on the head of a pin? The
I
answer is 40,000, more than 40,000, and you can analyze them while
I
you're
was gonna
synthesizing
I
them.
was gonna say 10 time what is it? Avogadro's number.
10 times 6.0 something.
Yeah.
02, yeah. So in a in a brand new nanoscale high throughput methodology developed in Denmark, the amount of material required to test molecular solutions to build maybe vaccines or pharmaceuticals agents has been dramatically reduced. The new tool speeds up development of all of this stuff uh, by more than 1 million times, according to researchers, while minimizing costs, of course, minimizing the energy and materials needed. And it gets results within 7 minutes. While this method is extremely concise, reduction in extraneous reagents, the name is a bit verbose. Single particle combinatorial lipidic nanocontainer fusion based on DNA mediated fusion, or as they have abbreviated it, sparkled. The method works by using soap like bubbles as nanocontainers with DNA nanotechnology. Multiple ingredients can then be mixed within these little bubbles. And you can do it on a mass scale, utilizing a bit of machine learning as well. You can run thousands upon thousands upon thousands of experiments simultaneously And again, results in about 7 minutes of what your outcomes are. This is quoting somebody. This is quoting Nikos Hadzakis, who's associate professor at the Department of Chemistry, University of Copenhagen. The volumes are so small. The use of material can be compared to using 1 liter of water and 1 kilogram of material instead of the entire volumes of water in all the oceans to test the material that would correspond to about the size of Mount Everest. So it's kind of a out there analogy, but it's massively, massively reduced the amount of actual material they need to have present in their experiments. And so this is sort of a trend. I've heard of other versions of this sort of that have been being worked on, being developed over the years. This is all a move to get really high throughput experimentation. This is the craziest scale of that I've heard. We've heard of versions of this in machine learning, trying to look at what the chemical interactions might be, but this one's physically doing the experiment. So great, you have the machine learning, the algorithm said, okay, we should put all these things together and see what they do because we think this looks like a good target, that looks like a good target, and then they come up with thousands of potential good targets. This is actually being able to put those molecules together and analyze how they interact. And then this is Meta Mela, who's one of the authors on this, saying saving infinite amounts of time, energy, and manpower would be a fundamentally important for any synthesis, development, and evaluation of pharmaceuticals. Meta is, I think, at the university, was currently postdoc at Harvard University, United States. What we have is
Harvard
a
Yard.
very close to live readout. This means that one can moderate the setup continuously based on the readings, adding significant additional value. We expect this to be a key factor for industry wanting to implement the solution. So yeah, there's all sorts of places and applications for this, as they've published in the journal Nature Chemistry. And there's a sort of fun side note where they discuss being afraid to talk about their project because they're like I was saying, there's like so much interest in this and there's so much research into doing high throughput. They didn't even, like, someone were like, I didn't even want to talk to my old professor about what I was doing because they didn't want, they wanted to publish first. They wanted to, that desire to publish the work and get it out there.
Well,
First.
if this is an area where people would jump on that and might throughput their work faster and get to publication faster. And there are, so many stories of reviewers denying publications and then going and doing the studies themselves and, studies being stolen. And yeah, but this is, the cost effectiveness of therapeutics, of finding molecules, of creating molecules, like all of it. If you can save companies money, it is worth so much.
Yeah. And Cody S is pointing out too about how machine learning, it's basically has to have the human knowledge input into it in the first place.
Yeah.
And so it's working with models of human knowledge that haven't actually necessarily been tested. So yeah, it's very tricky to rely on that. And especially if you get, okay, I need a solution for this and it gives you 40,000 solutions. And you're like, oh gosh, which one? Okay, I'll try this
Which
one
one?
first.
Yeah.
In a lab. Being able to connect a physical experiment to a throughput that is, much larger. Oh my goodness. That is going to revolutionize the way we look. This can be the time frame that we came up with the vaccines for the pandemic.
Yep.
Was amazing. Was actually unprecedented in a lot of ways.
Right, because we put so many resources behind it. And also it had been in development, not specifically a COVID vaccine, but
Yeah.
SARS and other mRNA vaccines had been in
Yeah.
development for
People of the
years.
future, and by future I mean maybe the next couple years, are gonna be like, wow, yeah, it took them like almost a year. We got this the next brain down. We took care of in 7 minutes.
Yeah.
Mm, okay. Well, comparatively, we're faster, but future people, future humans.
Future humans. I don't know. Hopefully, all these machines will be doing all the work, so it'll, keep us able to do all the fun, creative work that humans like to do.
Yeah, that's what they're gonna leave us to. It's like, yeah, industry's progressed to the point that we just need you to all do creative time now.
Yeah, just, oh, it's art time, humans. Go
Yeah,
get your crayons. Okay.
yeah, that would be fun. I like your vision of the future.
Well, let's look to the past very quickly for this last story for this first section of the show. Some researchers just from the University of Edinburgh have just published their results of a study in Science looking into how mammals survived after the dinosaurs all died out. So once upon a time, there was an asteroid, a big one, and then boom, boom, fires, climate change, no food, death, dinosaurs died. And, well, not all dinosaurs, we still have birds, but mammals, that allowed mammals to go burst out of their little hiding places and become dominant, or at least we like to think we are, dominant on the planet next to plants. Um, So these researchers looked into the question of whether or not it was because mammals were brainy and they thought their way out of problems, or whether it was because they were brawny and they stronged their way out of problems, or in any case, maybe intimidated or fought their way out of problems. So the researchers looked at body weight. They compared the sizes of mammals' brains, and you might go, oh, but how do they study mammal brain size when indeed there's really no soft tissue left over from those early instances of mammals, let alone dinosaurs? CT scans of skulls. That's what they did. So they took CT scans of skulls and were able to get the volume of area that the brains would have inhabited in these ancient animals. And by comparing mammal skulls and bodies from different eras after the death of the dinosaurs, they were able to determine that the mammals that survived initially after that great die off were the brawny ones. Body size increased relative to brain size. So brain size or stayed the same, but body size got a lot bigger. So basically, animals maybe got a little bit dumber, but they were stronger and they were able to get food. They were able to fight off competitors. They were able to intimidate. Brawn won at first. But then, when resources started to become scarce in different ecosystems because mammals had expanded and filled up so many niches, brawn no longer started to win. And it was the braininess of primates that allowed primates to start taking dominance in various areas. And so that's what they hypothesized based on their work and their comparisons of body and brain size through the years. Brawn was good when there was lots of resources and they needed to fight a lot. But then they needed to get smart. And here we are.
Yeah, there's one of the there's an idea that had not the mass extinction of the dinosaurs taken place,
Mhm.
that much of mammal evolution would have taken place anyway, and part of that is based
Yeah.
on the global cooling cycles. Because the mammals were pretty diverse. We weren't dominant by any means. We had a pretty diverse range of things going on back in the dinosaur days. But as temperatures cooled on the planet, that alone would have opened up a lot of territory that would have been sort of mammal only.
Yeah.
Like no cold-blooded dinosaurs allowed, or very few of them would have been able to handle some of the colder climates. So we actually could have had a planet that had both dinosaurs and some sort of like ape-like intelligent creature or intelligent mammal of some sort living on it at the same time. That would have been, a fun, you know, maybe we could really have the Flintstones. Could have been a thing.
Could have been, wasn't. Might be an alternate timeline. But this is This Week in Science, and we hope that you are enjoying the show. Thank you for joining us tonight. If you are enjoying the show, please share it with a friend today. Let's come on back for a little bit of COVID news. Pew. COVID, the fun that keeps on giving. The roller coaster ride you never wanted to get on in the first place. All right. There's a new variant. There's many new variants, but this new variant found in the UK is called XE. XE. It is the love child of Omicron BA1 and Omicron subvariant BA2. It's recombinant. It's these two subvariants that recombine and they're like, ta-da! And so now we have Z. And Z is potentially more transmissible than either BA1 or BA2. BA1 being more transmissible than previous variants, BA2 being more transmissible than BA1. So, yay, greater transmissibility. But we don't know whether or not it is any more dangerous or less dangerous. But because it is a recombinant variant of the Omicrons, researchers don't think that there is more of a public health concern than you would already have. That what we're looking at is probably going to end up being about as dangerous as the previous Omicron. Yeah, so again, there are also other variants. If you didn't know, this XE variant, there are other variants. There's XA, XB, XC, XD, and you haven't even heard about them because they weren't that much of a concern after they found them. But now the question is, how are we going to continue to find these variants now that many governments are reducing the amount of spending that they are putting into surveillance? The UK and Denmark, the United States have all begun winding down their testing and surveillance. And so when we do have case numbers, positive test cases, we don't actually understand how real those numbers are with comparison. It's almost as if we're going back to the beginning of the pandemic again because our surveillance is becoming less. Now, the World Health Organization has come out with a strategic document, and in that strategic document, they really say, hey, we should be putting money into surveillance. Testing is really great because then we know what's out there and what we're looking at. And in their most recent epidemiological report, I'm going to read from it right now. It's a little bit of a slog, but I think it's pretty important. And I hope politicians are listening. The World Health Organization is concerned about the recent significant reduction in SARS-CoV-2 testing by several member states. Data are becoming progressively less representative, less timely, and less robust. This inhibits our collective ability to track where the virus is, how it's spreading, and how it is evolving. Information and analyses that remain critical to effectively end the acute phase of the pandemic. Decreases in testing, unless done judiciously as a part of a strategy aimed at maintaining robust surveillance where it is most impactful, may affect the capacity of countries to identify cases and enable their timely treatment or isolation, and implement other necessary control measures, with the consequent risk of increased spread of SARS-CoV-2. This may translate in an increase in hospitalizations and deaths and significant strains on healthcare systems, particularly in areas where public health and social measures have been lifted and where vaccination coverage is in decline. Furthermore, reduced testing impacts the capacity of countries to detect emerging variants early, ultimately impairing response efforts. COVID-19 remains a public health emergency of international concern, and it's too early to reduce the quality of surveillance. The uncertainty around the characteristics of emerging variants limits our ability to confidently predict the behavior of this disease, as the evolution rate and risk of emerging variants are still high, which could undermine prevention and mitigation measures.
Yeah. Uh, it's just too bad this thing isn't more deadly.
I
And I mean
it's
that
it's a
literally,
terrible thing to
because
say, but I do agree with you, right?
we would
It's
have, if
just
it
enough.
was, yeah, if it was just much, if it was more lethal, if it killed more people quicker, it wouldn't have spread to this point. It's this sweet spot of transmissibility and lethality that's making this like the worst
Yeah. Yeah.
pandemic I think ever.
Because there's enough people who don't see it, who haven't felt it, who it's outside of their lives other than, their jobs being affected or other things, that it's just enough that it's there's deniability still, which, yeah. Anyway, it is killing a lot of people, and part of the way that it goes about its dirty business is by causing cascades of inflammation. And a new study out this week in Nature is looking into antibody mediated infection of blood monocytes. Blood monocytes are immune cells that are they're like the hall monitors in your
Yeah,
blood.
they can't be corrupted, because if the hall monitor's on the take, then
Yeah.
it's just going to be chaos at the school,
Yeah.
right?
Right. So these monocytes get infected occasionally, and the monocytes are like, no way. But SARS-CoV-2 is like, I'm going to divide or not divide. I'm going to replicate, replicate, replicate. And the monocytes are like, whoa, I can't deal with this. But they are infected and it's a problem. And they try to abort and call this abort system. But what happens is they the monocytes, because they are like the immune cells, right? And they're being damaged, they pull the fire alarm. They're in the hallway and they're like, fire alarm, fire drill. And so it causes the body to to help the infected cells die by pyroptosis or fiery death. And this is the initiation of inflammasomes. And the inflammasomes are like your body just goes, we're burning up. We're just going to burn it all. You burn it all down and we can rebuild. But, sometimes it's too much damage. And the way that your body reacts to that inflammation and the fiery death is not good. And that can lead to your death. So, researchers are saying that when this pyroptosis occurs, there's no way to treat it. You just have to control it as much as possible and hope that it goes out well on its own. Um, but the issue is that it's causing that problem. And so, for whatever reason, in this particular study, they compared people with COVID-19 and healthy people and people with pneumonia. Most of the people who came into the hospital with COVID had some amount of pneumonia as well. Um, but what they found is that people specifically with COVID-19 had higher levels of this pyroptosis. And so yeah, and so there's something happening in the way that SARS-CoV-2 uses antibodies to get into these monocytes that leads to this process, and somehow it does it better than other diseases like pneumonia. More fiery death from SARS-CoV-2, but at least now they're seeing what is happening, and so maybe now, you find these little pieces of the puzzle, and then maybe you can fix it. That's what we hope. No more fiery death. Or let's control the fire, a controlled burn.
Yeah. Yikes.
Yeah. I find it I mean, these kinds of mechanisms, there's a CNN Health article about this in which a researcher who is Donna Farber, a professor of microbiology and immunology at Columbia University, saying that this whole story that they put together, she said, "I think it's really elegant." And yeah,
Right. The scientists take it's like okay, stop appreciating the beauty of science for a moment.
just a
Remember,
moment.
fiery
Just a
death.
moment. Fiery death. Ah, fiery death. Yes. Sorry, Kev B. I wasn't trying to make fiery death sound fun and cute. Or maybe I was because, it helps us all get through it a little more easily. We've all been through it. This is This Week in Science. Thank you so much for joining us for another fun filled, science filled episode. We do appreciate you joining us, and we hope that you continue to enjoy all the science that we bring you week after week. We try and be transparent. We try to be credible. We try to have the best science news available for you and fun discussion of what's happening. If you do appreciate what we're doing, consider heading over to our Patreon account. You go to twist.org and click on our Patreon link, and you can choose your level of support. $10 and more per month, and we will thank you by name at the end of the show. We really can't do this without you. Thank you for your support. All right. This is This Week in Science, and we're going to come right back right now with, what are we coming back with? With a little,
I think
it,
it's time for Blair's Animal Corner with Justin and Kiki.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels.
Justin and Kiki's Animal Corner.
What you got, Justin and Kiki? Oh, I'm glad you asked.
We have so much science. What you got, Justin?
I've got camouflage. Whole
Yes, you
body
do.
camouflage.
Ooh.
Octopuses do it. Cuttlefish do it. So should we be surprised to see that squid can do it too?
No.
This is one of those things that I kind of, I wouldn't be talking about this probably if Blair was here. I'm pretty sure she would have scooped up this story. But I want to know what her reaction to this is. Published in Scientific Reports, scientists from the Physics and Biology Unit at the Okinawa Institute of Science and Technology have shown that some squid, at least, camouflage to match a substrate as a way of avoiding predators. So apparently this has never been seen before. Squid tend to live in the open ocean, so they're not around like the floor very much of the ocean. They are very hard to keep alive in captivity, and so maybe that's part of why this has gone unnoticed. But since 2017, scientists at the Okinawa Institute have been culturing a species of oval squid in captivity. So they've managed to keep them alive. Then they had an accident, or rather an accidental observation. Researchers were cleaning the tank to remove all the algal growth that had taken over the bottom of the aquarium when they noticed that the squid, who were still in the aquarium at the time, were shifting colors as they passed over the demarcation of the clean and the unclean part of the floor of their aquarium, and they're just quickly switching colors for their whole body to sort of match the substrate. So yeah, this and what we're seeing here is more of a controlled experiment. They follow up experiments on this. They kept several squid in a tank that had cleaned half of the tank, leaving the other half covered in algae. They placed the cameras in there so that they could capture, and these are the results. When they were on the clean side of the tank, they were light in color, and as soon as they move over to the algae-covered portion of the tank, they promptly become darker to match. Uncovering an ability squid were not somehow known to possess.
Did we not know that they have these color changing cells in their skin?
Apparently not. Or if they did, it might have been chalked up to, well, they have a common ancestor then with the cuttlefish and the octopi, perhaps, and maybe it was something that their ancestors shared in common, but now they don't have it now. But apparently, never seen this in squid.
I think this point is really interesting here from Dr. Ryuta Nakajima. If substrate is important for squid to avoid predation, then that indicates that increases or decreases in squid populations are even more tied to the health of coral reefs than we thought.
Mhm.
Which is, I think that gives, the conservation angle on this is when we understand more about how animals live within their environments and how they interact with their environments. And something like squid, octopus, cuttlefish, who are using the coloring of the substrate. It's not just, oh, a tank substrate. It's like they are using their surroundings in a coral reef to determine how they look. And I just wonder if they would be like octopuses or cuttlefish. We haven't seen it,
Mhm.
possibly using color since they can change color. Have we not seen them use color to communicate? Like, there's so many more questions that I
Mm.
want to know about the squids.
Yeah.
I want to
I
know
want to see.
all.
I want to now. I want to see a giant squid doing this.
Changing colors.
Well, they got to test all the other squid now, right?
Yeah.
Because this is just one species of squid. What if it's the only one that
Yeah,
can
these
really do this?
cephalopods and their color changing abilities. It's so interesting. Yeah. And also their vision, right? Squid eyes. They're really good eyes, but if you're changing colors all the time, what are you looking for in another squid? What are you checking out in your environment? Like,
Yeah.
I think this is going to be very interesting squidly research.
Mhm.
Oh, I wait till the researchers get it into their little tentacles. What about bats? Do
Uh,
bats don't change color? No, bats go, they hide in their caves during the day, except for the daytime bats, those
there's a lot of
diurnal
bats.
bats. There's a lot of bats. Some bats are diurnal, some are crepuscular. Most are nocturnal. We like to think of bats as the bats that come out at night and then go back in the day after they've done all their eating. Vampire bats in particular, we know they roost in groups and they have very strong social bonds. We know that vampire bats share blood with each other so that if one bat in their little social group is hungry and didn't find enough food, they will regurgitate blood meals for other bats in their group, that there's this reciprocal arrangement in sharing food and meals. And these these bats, they know each other. They hang out. They have long-term relationships. And that's all well and good when you're growing up with your family in your neighborhood. You're just all you go to your school and all that kind of stuff. You're like, this is my neighborhood. These are the bats in my neighborhood. But what about when you go off to college as a bat? Do you
Hmm,
bond with your college roommate?
wait a
What kind
second.
of
There's bat college.
Well,
No,
apparently at Ohio State, some researchers gave bats the equivalent of college roommates. They published their study in the journal Biology Letters, and the researchers they wanted to see they wanted to test interpretations of how relationships form in how social bonds form in vampire bats specifically. How do they form their relationships? And so they forced young bats to live together with another bat for 1 week. And then they tested the bats to see how long those relationships lasted. They used a camera system to identify the bats and then be able to, with infrared surveillance, be able to follow the bats multiple hours a day to be able to see who they were grooming, who was grooming them, who they were hanging out with. And during the various study phases, they also, they were looking at bat grooming interactions of 5 seconds or longer. And so the researcher says from early on, they had potential to start grooming relationships. And then we did the forced proximity phase to see if we could increase rates of grooming in random pairs. We then measured grooming during the post treatment phase to compare pre versus post treatment grooming. Turns out, bat college roommates have long lasting relationships. They're not like me and my college roommate.
Oh,
Who never spoke again
oh
after that
no.
that fateful year.
Oh no.
Um, during the forced proximity phase, they had 2 partners they could interact with. In the post treatment phase, they had at least 20 other available partners. They knew some beforehand. So some of them, they had friends before, and then they were like, oh, here's my college roommate. Um, and the researchers say, so the fact that the preference was visible and clear and throughout the entire 9 weeks is a meaningful result. And the effect was clear in all the ways we statistically analyzed the data. So they don't really understand how social bonds form in the wild from this particular study. But what they did determine is that living in close proximity is what is required for building a relationship in these bats. Living in close proximity made the bats better friends,
Yeah.
a stronger relationship than just having come from the same general area where they had been trapped or grown up.
Yeah, there's not a lot of online relationships in the bat community or long distance pen pal phone call kind of things going on either.
Hey, college roommates. Call it bat college roommates. Don't drive them batty. They become friends. Isn't that
Hmm,
nice?
nice.
That's nice. Oh, hey, it's This Week in Science. We love This Week in Science. You love This Week in Science, right? Do you love it so much that you want to buy a t-shirt? Yeah, I bet you do. Head over to twist.org and click on our Zazzle link. We have some new shirts and pillows in the store. I hope you take a look at them. All right, Justin. What is Justin?
This just in. Hi. So this is kind of an interesting one. The EPA, Environmental Protection Agency, has proposed a new rule to ban asbestos. Now, if you're of a certain age, you may remember a time when asbestos was being removed from buildings around the world due to its cancer causing ways. It was a huge deal. Yeah, it was in everything: homes, offices, hospitals, schools. They all had asbestos, had to be removed. There were hazmat dressed crews that were coming in and doing these removals at tremendous risk. It had been put into the buildings over the years as I believe, as a fire retardant or to reduce fires or something like this. But it turns out the asbestos way more dangerous than fire. Um,
Oh, we've known that.
yeah, spent a lot of money getting it out of buildings throughout the 80s. And so you might think, okay, why is the EPA now banning asbestos if we already got rid of it? And the answer is because we didn't. You might think
What?
that we did,
What?
but we didn't ban it. Actually, they did. I take that back. They did ban it in the late 80s, but then chemical lobbies with some congressional help, I believe. Remember tort reform that
Oh,
was being
yeah.
talked about?
Yeah.
One of the big focuses of that was mesothelioma, which
Yeah.
sounds like a word. And you probably, if you had a TV in the last couple decades, you probably saw commercials. mesothelioma. If you think you have, if you want to settle, if there's a case, there's a lawyer commercials for, if you have this disease. Turns out that's just from asbestos. That's the cancer you get from asbestos. So there's all this like trying to limit damages to that industry and trying to prevent the EPA from being able to enforce its ban. And it was successful. In the early 90s, it was successful in keeping big portions of asbestos in operation, creating phase outs or just keeping it. There you go. 2016, I guess that would have been the Obama administration, passes a new law that gives EPA more power to tackle toxic chemicals that are being used by industry or out there in our society. And so now, finally, under this new law, they have opposed a rule that would ban asbestos completely. Okay, so the only real place that we're
I'm
using
laughing.
it,
So.
yeah,
What?
is calling this. EPA has come out and just said we're finally putting the end of the use of this dangerous asbestos chemical in the United States. And so it's like, okay, you've finally gotten rid of it. The American Chemical Council, or excuse me, American Chemistry Council, which sounds sciencey but might not be, is a lobbying group for the chemical industry. They attacked the EPA proposal saying you can't get rid of asbestos because it could cause substantial harm to America's drinking supply. So in the need for clean water, they're saying, and this is like, wait, you're arguing on behalf of clean water, but against banning of asbestos? What's going on here? And it turns out chlorine is manufactured utilizing asbestos.
Asbestos. Okay.
And chlorine is used about 98% of public drinking water in the United States. And the water treatment facilities, they use some form of chlorine-based disinfectant. And so they're worried about supply chain disruptions as they look for different ways to form chlorine. It's not the only way chlorine is used. It's also used in batteries, windmills, solar panels. They're still not made out of honey. They got asbestos involved in there. So there's always an argument to be made by keeping some of these toxic chemicals, because used correctly, as you might assume, they would be just fine. But it's also sort of like hard to understand, like, wait, America's clean drinking water has
Relies.
asbestos?
It doesn't have asbestos in it, but the chlorine relies on asbestos. So it's
And there are types of chlorines that are created with asbestos filters.
Yes.
This sort of thing. It's most consumer products. It's already gone. But I don't know. I thought it was sort of interesting because I thought asbestos was out. Like that was such a bad thing that you would not be still utilizing it.
Yeah, the fact that we're still utilizing it is odd, but at the same time, just can we just get it, not put it in buildings anymore, not use it in relation to people's breathing, because that's the big one. Those fibers, those little shards, the fibers that get in there and get you.
And then
And if it's still in your mother's house, leave it in your mother's house.
Oh yeah, don't touch it.
Don't take it out. Don't touch it.
Yeah. And as fun as it is to draw with your finger on lead paint,
Don't do that.
Don't
do that either. Nope.
But that's like one of those things. Like if somebody was like, "Yeah, we're going to get rid of lead paint now," I was like, "Wait, what? How could we not have done that already?" Which
lobbying
we did.
industries.
That one's
fantastic. Done. Okay, tell me about what is this? Evolution and
so evolution states blanket all species of organisms have developed through the process of natural selection. There's inherited variations that over time increase or could even decrease, I suppose, an individual's ability to survive, to reproduce. This is the basic idea of evolution. But and we've of course it's been proven out from genomics to zillions of studies that have taken place. Evolution's a thing. In the darkest of interpretations, however, it is coined survival of the fittest. And it is occasionally used as a straw man argument
Yeah.
against the theory of evolution and against science in general as being a philosophy that is bereft of any compassion. Because, oh, if it's survival of the fittest, then it should just be a dog eat dog world. And that's what the scientists think, which is not a thing, but it's a straw man argument where you created a fake, which I've just done too. I've also created a straw man to exhibit the straw man. But
It's good
that's
to use
that's all
use your
fair and
examples. Yes.
straw man, or and then it's also been used by eugenists to claim scientific rationales for bigotry and pseudoscientific um, race-based nonsense. It turns out, though, understanding evolution might actually have the exact opposite effect of those. This is according to the University of Massachusetts Amherst research published in the journal Personality and Social Psychology. Says disbelief in human evolution is correlated with higher levels of prejudice, racist attitudes, and support of discriminatory behavior against minorities, immigrants, and the LGBTQ community. And it's not just in America. This is across the globe. They did also had 19 Eastern European countries, 25 majority Muslim countries. Israel was in this. And across everything, low belief in evolution was linked to higher bias, prejudicial attitudes towards others, and also, interestingly, less support for conflict resolution.
Oh, interesting.
Yeah.
No, we don't have to resolve the conflict. Fight it out.
Yeah.
Just
Yeah. So
fight it out. There we go. Okay.
researchers analyzed data from the American General Social Survey, Pew Research Center, a bunch of online crowdsourced samples. They accounted for education, political ideology, religiosity, cultural identity, scientific knowledge. They had all this in there. And they found, though, that the believing in evolution relates to less prejudice regardless of what other group they were in. There weren't like more prejudiced people who believed in evolution in one group and less across categories. Belief or understanding and process of evolution was connected and correlated to being less bigoted. So religious beliefs and political ideology were measured separately from all of this. Again, evolution remained the consistent thread between less prejudiced response. The data showed unfailingly that the disbelief in human evolution is a driving factor and most consistent predictor of prejudice in comparison to other things. So if they took the data and just said, okay, now we have this group. These ones say they believe in evolution. These ones disbelieve it, and they predicted what would happen, and it followed suit. The Israel-based study, people with higher belief in evolution were more likely to support peace amongst Palestinians, Arabs, and Jews. And the study involving Islamic world, belief in evolution was associated with less prejudice towards Christians and Jews. The study based in Eastern Europe, where Orthodox Christians are a majority, a belief in evolution was linked to less prejudice towards gypsies, Jews, and Muslims. The findings suggest that teaching evolution seems to have a side effect that might make for a more harmonious society. That's all we got to do. Teach the evolution. Science, of course. Makes sense.
Right.
Solution
I
to
mean,
everything.
well, I mean that it's also a, it's a litmus test to find out what kind of a
Mhm.
person you're talking with. Oh, what are your thoughts on evolution?
Right. And there are sort of I'm very curious too, because then if
Yeah.
that trend continues, there's also our groups in which there are more or less people who will believe in evolution. And so then it would be sort of interesting to to follow that thread through these other groups and see if that also. But I love that that's just the thing. I've always had this sort of idea that if you could separate all the people in the world into just like-mindedness, you'd have these really interesting pockets, right? There'd be the town of the science-minded folks where everyone's working either for towards a brighter future, working in the lab doing experiments, or they're just spending all of their free time going to interesting talks by
Right.
someone, right? Right? And then you got the music town where it's like people who like to dance move there, but it's also musicians. There's like endless jam
What
session
about
of
the
street
scientists
performance,
who are musicians? I mean, the
music
problem
halls,
is there's
recording
so much
studios.
overlap.
Right, right, right. And you'd have the fashion focused town where people are
Yes.
all dressed amazingly and they got all this great clothes. And then there'd be the racist town because that's a thing too of like-minded folks where all these
Yeah.
people they just couldn't even wait to move there so they could be in a town consisting of only their own kind, and then once they get there they quickly discover that racist people come from every ethnicity and every religion in the world, every political background. So
Yeah.
all the
Yeah.
racists go and they find, yeah, you're surrounded by racists in a multicultural
Prejudice
melting pot of bigotry and
prejudice
xenophobia.
prejudice knows no boundaries.
Yeah. And so
Ugh.
I guess what the world really needs then is we got to talk about evolution more. We got to
Yeah.
bring that subject here more often.
Yeah, I love the idea that by understanding evolution, it gets you more in touch with the animal kingdom in general and more connected with life on Earth, which then can lead you to a more harmonious view of of everything. Um, yeah,
One of the
we'll
things that
see.
they kind of
We'll
one
see.
of the things they kind of point to is if you have it in your mind that humanity has a shared history, shared origin, a shared history that we've sort of all been in this together, then it you're less likely to other the other people in the world who
Yeah,
maybe think or look differently.
maybe it's a step in that direction.
Hmm.
We can only hope. But in the
Yeah.
meantime, I want to talk about fungi. Can we can we talk about how funguses are communicating and they're going to take over the world?
Oh goodness. So we've done
Okay,
all of this for nothing.
but then
All
we've
this
done
evolution, all this trying to
yeah.
get along, all this fighting about stuff,
We're
and
just
fungus is just going to swoop in right
funguses.
here,
Yep, they're
take her.
swooping in. Swooping in. Researchers publishing in the Royal Society Open Science Journal. They're a researcher, Adam Adamatsky. His paper, Language of Fungi Derived from Their Electrical Spiking Activity. Dr. Adamatsky has taken fungi and recorded their electrical activity. And in recording their electrical activity, was able to discern, as people have previously, that there seem to be distinct differences in the electrical uh, potentials that are recorded in different places in the fungus in response to certain things the fungus is doing. So, for example, the fungus uh, is burrowing its way through some kind of substrate. And it's reaching out little tendrils of the mycorrhiza to kind of burrow through. It has one particular kind of signal. If it reaches a hardwood block, there's a different kind of signal. There are different electrical potentials, and so coming from a perspective of natural machine learning and also language production, this researcher has looked at these electrical potentials from the perspective of syntax, grammar, structure, and determined that there are very specific signals that are being propagated for very specific reasons. Whether or not this is language, like whether yo, I found some wood to eat, whether it's language per se, whether there's, real grammar, words, reflecting symbols, that is highly unlikely. And I would debate it very fiercely. But the concept that there could be repeatable, standard electrical signals that occur in response to regular, repeated stimuli that that a fungus might come in contact with. This is fungus is multicellular. A fungus will move into its environment. It comes into contact with dirt. It comes into contact with plants. It comes into contact with other funguses. It comes into contact. It has to communicate within itself related to here's a food source, here's water, here's nutrients. There are messages, chemical or electrical. We know that there are electrochemical signals being sent. So there's no nerves, but there is conduction. And it's regular and it's repeatable, at least in a couple of different species. And the big question is, are these signals the same across all fungus species, or are these signals species dependent? Are they environment dependent? We don't know any of these things, but it's an interesting question, and it's an interesting perspective to be looking at the electrical communication, the electrical internal communication of another organism in this particular way. And could it lead us to interpret signals from alien life at some point in the future? That's the next big question.
That's a very interesting question, actually,
Yeah.
because part of what we're talking about is we can think of as automatic communication, unintentional communication, right? This is what we're determining as a communication is just a response seen over a thing. Much of the way that we can, though, see this sort of take place in the brain when a brain is having certain types of activities, you can see certain types of electrical output from a brain, kind of a thing. Does it mean that it's communication, or is just this an affect of its activity and that sort of thing? And so we might assume too, like what you're saying, that the alien life would be sentient and have that part of the brain that controls logic and engages in things separate from sort of an automatic. What if the aliens show up and they're just on automatic fungus pilot?
Right. And
And
so
that
there
led to
and
space travel at some point.
yeah, and
Whatever planet they're
there's
from.
another study that's also out this week that discusses how slime mold, which we know as a unicellular organism that has really interesting communication within itself, it also can act as a multicellular organism when it's feeding on bacteria. And so you give slime mold a big bacteria clump to feed on, and it goes wild, and it's like, yeah, let's feed lots of different cells, and those little cells eat and fruit and do all sorts of stuff, and then they're like, oh, it's time to grow, we will be one. But they communicate that somehow. There is chemical, and there is communication happening, right? These slime molds, these funguses, they don't have nerves, they don't have a brain in the sense of a brain that we have, but they have behavioral capacities. They are able to survive. They exist, they change, they adapt, and they survive.
Hmm.
How do they do it? How do they do it? Yeah, so the abstract of this paper in the Royal Society says, assuming that spikes of electrical activity are used by fungi to communicate and process information in mycelium networks, we group spikes into words and provide a linguistic and information complexity analysis of the fungal spiking activity. We demonstrate that distributions of fungal word lengths match that of human languages. We also construct algorithmic and Lizempel complexity hierarchies of fungal sentences and show that species S commune generate, and S. Schizophilium commune, generate the most complex sentences.
Hmm.
So there's differential complexity. I mean, the
I'm
question
wondering.
is this an appropriate interpretation of the results? Is this actually, based on what we're looking at, an appropriate comparison against human language? I'm going to argue it's not, um, but it is
I'm
an interesting approach to studying this question.
I'm going to actually take the other side then and say not only is this articulable language, but I believe network TV has been using fungi to write their shows for a long time, and we're just now catching on to them.
Oh, the fungal networks. I mean, that's why it's network TV.
Yeah, that's why. How do you think it's a coincidence? I tell you, it's been in
Yeah.
it's plain sight, hiding in plain sight this whole
Hiding in
time.
plain sight. We know that our brains shrink as we get older. They expand and grow when we're younger. But recent work has suggested that the majority of fMRI research is limited because of sample size, that the results that we've gotten from many, many studies probably should have had many, many more brain scans in them than they did. So, there needs to be greater sample size in order to have reproducibility. Knowing this, and also having a young son, neuroscientist Jakob Seidlitz uh, decided that they needed a metric for brain development, and it just wasn't out there. We know that there's changes in the brain throughout life, but what happens really? And so Seidlitz accumulated, was able to gather, sending emails to different researchers around the world, was able to gather more than 120,000 brain scans
Oh,
to create comprehensive growth charts for brain development. So we know that, Justin, you take your new son into the doctor, and at one point they say, "Oh, your child is going to be 6'2", or your child is going to be 5'4", or you can expect this based on height and blah 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 blah." We don't have that for the brain. And so this is what Seidlitz has created, publishing the study in Nature this last week. They have created an MRI growth chart for brains. Brain scans do vary significantly from person to person. And so that's one of the big challenges about creating a predictive chart to be able to give to pediatricians. There's a lot of training that would need, or interpretation that would need to go along with brain growth charts to help pediatricians understand that, oh, a big brain isn't necessarily one that's functioning really well. A small brain isn't necessarily one that's not functioning very well. There are aspects to these charts that would definitely need to be tweaked to allow them to exist in clinical settings and beyond the scope of this study. But it is an important start to really understanding how the brain changes throughout development for a human being. And we've never had
yeah.
this before. Pretty amazing. One thing I love about this story is that Seidlitz thought that that they got a lot of replies to the emails they sent asking if neuroimaging researchers would send them brain scans. They were, wow, everybody wanted to share them, but they think it was basically because people were bored because of the pandemic.
A little bit of downtime
Little
does
down.
help for some of those collaborations where you got to look up something.
Yeah.
It is interesting what you said about the doctor has not given any estimations on height of the child, but he's
That
been
happens later.
growing. He's been growing at a centimeter a week, which is a
Nice.
little frightening because that would, I did my own calculation, and it turns out by the time he's 10 years old, he should be about 18 feet tall.
Oh, Grow, kid,
So
grow.
I need to like figure out how to feed this monster.
keep keep feeding him. He'll be the
Yeah.
tallest kid in the world. One thing that was surprising, we know that in late adulthood, what you have is yes, there is a small amount of shrinkage of your cortical regions and other areas of the brain. But the thing that starts to grow are your ventricles. The ventricles are the fluid containing spaces within your brain. And surprisingly, there is a rapid increase in the size of your ventricles from about 50 years of age onward.
So there's
Woo!
so we
My
don't want
ventricles.
that,
Well, not necessarily.
or
It's
do want
associated. They associate it with aging and mental decline.
which
Um,
what do just tell me how I'm supposed to grow my brain, Kiki, and I'll do it.
well, the normal is that your ventricles grow, but I
But
don't
I
want
don't
mine
want to. I
to.
want to be normal. I don't know if I like the idea of being average. It
I don't want my
sounds
ventricles to grow.
terrible.
You don't want to be. You don't want to be
I've seen the average. I was not impressed.
average. And moving on to my last story, beyond the average, beyond brain growth charts. Um, One thing that's standing in the way of creating synthetic brains using artificial neurons and even um, artificial intelligence with neural networks is our understanding of the brain architecture. And so, Blue Brain, which is a project, the Big Blue Project, is out of EPFL, and they are working to push forward artificial brains. And so what they have created is they're using algebraic topology, which is a math field, understanding the surfaces of objects. They've developed an algorithm that can artificially generate large numbers of unique nerve cells. So from a small number of starting cells, the algorithm can then create a brain. What they call this algorithm is the topological neuronal synthesis, and it can synthesize millions of unique neuronal morphologies. In being able to do this, they've published a paper in Cell Reports, and it categorizes dendritic morphologies reliably to digitize synthetic dendritic morphologies from all layers and morphological types of the rodent cortex. This is going to enable the rapid digital reconstruction of the entire brain regions from relatively few reference cells. And understanding the structure, the architecture of the brain can potentially help us understand the function of different areas of the brain, specifically what goes wrong in disease when some of the structure is damaged. So, one day, artificial brains will enable us to not have to use brains to study brains. But until then, it's all brains all the way down.
It's
What do
also
you think? What?
yeah, I I I still want I want a little bit of artificial brain. Now that I know my ventricles are going to be full of fluid at some point,
There we go, right?
I want the artificial brain that I can use.
You're gonna get
I want
so
access.
so your ventricles are growing. So what we're gonna do is we're gonna get you a honey neuromorphic tech chip that
Yes.
has been designed by the topological neuron synthesis algorithm
Yes. Here we go. We're
to
putting it all together.
maximize your mental function. Yes.
And how are we going to make all that happen? We'll just run it through the sparkled uh, machine, and that'll give us our solution 7-8 minutes tops.
And thank goodness we have all this technology to help us live longer, better, and more smarter because of course we're gonna fix climate change with
Yeah, well, because we're going to start thinking harmoniously and caring about each other, because we're all going to learn about evolution.
this makes so much sense.
It does. I think we have a good plan.
I think this show brought it all together. It's a good thing we're at the end of the show now. We did it.
Yeah, or it might start falling apart again.
I know. Don't break it apart. We have a nice little package, tied it up in a bow. Thank you for listening. I hope you enjoyed the show. I would like to give shout outs to the helpers of the show. Fada, thank you so much for your help on show notes and social media. Gord, thanks you. Thanks you? Yes, thanks you. Thank you for being in the chat room. Identity 4, thank you for recording the show. And Rachel, thank you for editing. I'd also like to thank our TWIS sponsors. Thank you to Teresa Smith, James Schaefer. James Chauffeur. Tell me if I'm pronouncing it wrong. Send me an email. I will fix any name mispronunciations that I may have. Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazar, Ralphie Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Woody MS, Chris Wozniak, Dave Bunn, Vigard, Chef's Dad, Hal Snyder, Jonathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Ragan, Don Mundus, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredus 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Shauna Nina Lamb, John McKee, Greg Riley, Mark Hesseflo, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Artyom Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Drapeau, Sue Joster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve Rebell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecorari, Tony Steele, and Jason Roberts. Thank you for all of your support on Patreon. And if you would like to support us on Patreon, head over to twist.org and click on that Patreon link. On next week's show,
we will be back Wednesday, 8 p.m. Pacific time, broadcasting live from our YouTube and Facebook channels and from twist.org/live.
Yes, we will. And, yes.
Hey, you
want to listen to us as a podcast? This show, it's a podcast, has been for a long time. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe too.
For more information on anything you've heard here today, show notes, links to the stories, papers, maybe even that they were based on, available on the website, www.twist.org. You can also sign up for a newsletter, which there's like 2 a year. So it's not like a big commit.
It's not a big commitment. But it's a fun commitment. It's really good. You can contact us directly. Email me, Kirsten at thisweekinscience.com. Justin, that's him, at twistminion@gmail.com. Blair, who's not here, at blairbaz@twist.org. Put TWIS in the subject line so your email doesn't get spam filtered into a mycorrhizal network of fungal communication languages and really would be spam.
Yeah. You can also hit us up on the Twitter where we are at TWIS Science, at Dr. Kiki, at Jackson Play, and at Blair's Menagerie. Love your feedback. Topic you'd like us to cover, address, suggestion for an interview, haiku that comes to you tonight, please let us know.
We're going to be back here next week. Yes, we will. And we hope that you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science.
science. This week in science. This week in science. This week in science.